Hello everyone, this is Joshua, a registration number UR1 for CS123. So this video is in regard to the fourth experiment of a Unix lab in which we deal with basic, I mean, various base conversions. So in this first program, we convert a decimal number to various bases such as binary, octal, and hexadecimal. So well, first the numbers to be read, and then the options are displayed using the echo command, and then the output is read. And then in the case statement, we branch the program to three parts. One is for the conversion of binary, hex, the other for hexadecimal, and the other for octal. So first of all, for the binary one, we have to check whether the number is equal to 0 or not. So if it is not equal to 0, only then we can continue. So while the number that the person has entered is not equal to 0, we find three parameters in order to convert the decimal number into binary. So first of all, the number is the modulus of it is found by 2 with 2 modulus of it with 2 is found out, and then the bin variable just echoes the remainder, that is what is got from here, and the binary number, and then the third variable is divided by 2, and once this is done we get the binary equivalent, and then we just display the bin variable. Now for octal, again we have to check whether the number is equal to 0 or not. And here, just because the base is 8, we have to find the modulus and divide by 8. Using the same logic we used in the binary, we just replace 2 with 8 and we just display it. And now for hexadecimal, it's the same thing, but here the number is not equal to the same thing, and we have to check whether the number is null or not. And then the base here is 16. But in hexadecimal, there are various notations used. For example, for 10, the ASCII characters are used. I'm sorry, not ASCII. For hexadecimal, the various characters are used. For 10, it's A. For 11, it's B. For 12, it's C. For 13, it's D. And 14, A. 15, F. And accordingly, the hexadecimal number and the number is displayed. Now let's run the program. So I enter decimal 123 and I convert to binary first. And this is the binary equivalent to 123. And I try converting it to hexadecimal. This is the hexadecimal value. Okay. Now moving on to the next program. This program converts binary input into various other types, decimal, octal, and hexadecimal. So after taking out all the inputs, we first of all in the first case statement, binary to decimal, I declare a variable POW as 1, initialize it as 1, and while the number is not equal to 0, I find the remainder and a temporary variable using the necessary mathematical expressions. That is, first I find out the modulus with 10, then I divide it by the POW, that is 1, and then the decimal is added with the temp variable, the result found from here, and it is divided by 2 and then by 10. And once this is done, the decimal is displayed. The same logic we use for binary to octal. Uh, while the number is not equal to 0, the remainder variable will be the modulus of it will be found out with 10, and the temp variable, the remainder, and the POW variable, and the decimal variable here, it is added to the temp variable. That's the result found from these two, and then the POW here is divided and multiplied with 2, and number is divided by 10. Now while this is done, we found out the decimal value, and while the decimal from this is not equal to 0, first of all, in order to convert it to octal, it first has to be converted to decimal. So first that is done, and it's not equal to 0, we do the same thing as we did in the previous one. So we divide it by 8 and then find out its modulus with 8, and etc, etc. And for binary to hexadecimal, we do the same thing. First we convert it to decimal, then while the decimal is not equal to 0, we find the modulus of it with 16, and same conditions here too. 10 is for A, 11 is for B, 12 is for C, and so on, and we can just display the values. So I enter a binary number, so I convert to decimal. This is the decimal value. Moving on to the next program. Now here we convert various octal inputs to various other types. So first of all, we use the same logic as we did in the previous. First of all, the octal number is converted to decimal. So the same logic is used here as it was used. Only thing is here, just because the input is octal, the number here instead of 2 is 8. And the second thing, octal to binary, it's the same thing. First we convert it to decimal, and then we convert it to binary. So once the number is converted to decimal, then decimal to binary is already known to us but from the previous programs. Octal to hexadecimal is the same thing. First it's converted to decimal, and then it's converted to hexadecimal using the previous. So when this program is run, I enter an octal number, say 24. I convert decimal, it's 20, and I convert it to binary, it's 10100. Moving on to the last program. Various hexadecimal inputs are converted to other types. So the same logic is used here. I'm sorry. Uh, First of all, when the hexadecimal number is entered, then the user has to select from the operations whether binary, decimal, or octal. So for the first thing, for hexadecimal to decimal, we just echo the base as 16, because for hexadecimal input the base is 16, and that is done. And then we use the BC command. We use a pipe command here, and that is what the decimal value is displayed. And then for hexadecimal to binary, since the output base here has to be 2 and the input base here is 16, so when you use the BC and the pipe command, it is done here, the conversion is done. And same thing for octal. Here the output base has to be 8 and the input base as I base is 16. That is what we are giving, and the output is displayed. What is happening here is I first enter hexadecimal value, say 322, and I convert to decimal, and so each number is ungrouped and then accordingly converted to various other formats. So I enter another same number and convert it to binary, and it is this. So that's it for the fourth experiment. Thank you.